So good day, engineers. This is actually a continuation of our discussion last time. So our next problem is problem number 3. An open cylindrical tank 1 meter in diameter, 2.5 meter high, is 3/5 full of water. We have to determine the angular speed in RPM if the base uncovered is within 20 centimeter from our vertical axis. So when we illustrate it, it will look like this one. So we have a 1 meter diameter tank, 2.5 meter high, and 3/5 full of water. So this will be the same for our last example. 1.5 meter and 1 meter. So it is actually rotated about its vertical axis. By an angular speed of omega. Now, it actually uncovers a base of 20 centimeter or 0.2 meter from our vertical axis. Now, on the other side, we also have 0.2 meter from our vertical axis. So your paraboloid will actually look like this one. So meaning, as our angular speed goes higher, or as the value of our angular speed goes higher, the only liquid that will be retained in our tank is this one. So we can actually conclude that some liquid will be spilled in this situation. So as we can go back with our last problem, the angular speed for the vortex that will just touch the bottom is 133.758 radian per revolution per minute. So we can expect that our angular speed in this problem is greater than this one. So this angular speed is actually the limit wherein your vortex will be at the bottom of your tank. So since our vortex is already lower than the bottom of our tank, we can expect a higher angular speed. So to solve this kind of problem, we actually have to recall our learnings from our past subject. So we have this so-called squared property of parabola. So the squared property of parabola states that the x sub 1 squared over y will be equal to x sub 2 squared over y. So we can actually get a parabola from our drawing. So this is the parabola. We'll just take the half of this one and it will look like this. So this is actually the radius. So since our tank has 1 meter diameter, this will be 0.5 meter. Now this one, this will be the uncovered base, so this will be 0.2 meter. This one is actually the height of your paraboloid, and this one is the height of your tank, that is equal to 2.5 meter. So by squared property of parabola, we can say that 0.5 squared over height of our paraboloid is equal to 0.5 over height of paraboloid is equal to 0.2 squared over the this value. What is this value? This is actually height of the paraboloid minus 2.5. So this will be HP minus 2.5. So simplifying it further, this will be 0.25 over height of paraboloid is equal to 0.04 over height of the paraboloid minus 2.5. So by cross multiplying 0.25 multiplied by height of paraboloid minus 2.5, that will be equal to 0.04 height of the paraboloid. So 0.25 height of the paraboloid minus 0.625, that will be equal to 0.04 height of the paraboloid. So transposing this value, 0.25 minus 0.04, height of the paraboloid is equal to 0.625. So 0.21 height of the paraboloid is equal to 0.625 over 0.21. Height of your paraboloid will be equal to 2.2 2.976 meter. So going back with our formula for height of the paraboloid, we can say that 2.976 is equal to W squared R squared over 2G. So by simplifying it, we can say that 2976 is equal to omega squared R squared 0.5 squared over 2 times 9.81. So our omega squared is equal to 2 times 9.81 times 2.976 all over 0.5 squared. So extracting our square root, so your omega will now be equal to 15.28 rad per sec. So converting it to revolution per minute, 15.28 times 30 over pi, that will be equal to 145.94 revolution per minute.